Okay, this is the last video in section 4.1. We have already covered all of the basic goals of the section. We want to go back and emphasize a few points. So in this video, we'll talk a little bit more about whether a function is one-to-one. And then we'll also talk about finding an inverse from a formula, or we say find an inverse symbolically. So in example 6, decide whether each function is one-to-one. If it is, find the equation of the inverse function. And so we look at this first function, x squared plus 2x minus 3. Probably the easiest way to do this is to think about the graph of f of x. What does that graph look like? That graph is a parabola. We know that it opens up. Doesn't matter. If it's a parabola, then it will fail the horizontal line test. Horizontal line hits twice, and so we can say no, f of x is not one-to-one. And we can just stop right there. I want to mention in an earlier video when we were looking at y equals x squared, we said that it's not one-to-one, and then we went on and we restricted the domain so that we could define an inverse. And in theory, you could do that with this function as well, but that's not necessary. We wanted to do it with y equals x squared because that's such a fundamental function, and because its inverse, y equals square root of x, is another fundamental or basic function. But in general now, we can just stop. In this example, in example 6a, we can say it's not one-to-one, and we can stop there. Okay, let's go on to part B. This time we have x minus 4 quantity cubed. Again, if you know what the graph looks like, then that's probably the easiest way to determine if it's one-to-one or not. So this is the graph of, this looks like the graph of x cubed, except the minus 4 shifts it over. But that won't affect if it's one-to-one or not. So what does the graph of x cubed look like? It looks like that. It is one-to-one. Yes, it is one-to-one. And so we can go on and find the inverse, find the inverse function. We laid out a 4-step process to do that in a previous video, but we only did one example. So let's go through and let's go through that 4-step process again. So let's go ahead and remember step 1 was replace g of x with y. G of x is a little burdensome, or it's a little cumbersome when we go and we switch x and y in the next step. So y is a little simpler version of g of x, and so it makes our work a little easier in the rest of this problem. So we're going to go ahead and write y equals x minus 4 cubed, and then we can go on to the next step, which is to switch x and y, which is essentially what it means to be an inverse. And so we can write x equals y minus 4 cubed, and then all we have to do now is solve for y. So it might be nice if we just go ahead and switch the two sides. Usually we want to wind up with y over on the left side of the equal sign. So if we just write y minus 4 cubed equals x, that's a good start. And then if we want to solve for y, we're going to take off the cube, and then we'll take off the 4, and then we'll be done. So to do the opposite operation for the cube, we'll take the cube root of both sides. The cube root and the cube cancel, and we're left with y minus 4 equals the cube root of x. And then when we add 4 to both sides, we get the cube root of x plus 4. Make sure the plus 4 is not underneath the radical. And then the last step is just to call this function by its formal name. Let's see here, since we started with g of x, then this will be g inverse of x. So call the new function g inverse of x. Replace y with g inverse of x is what we mean. And so there's our answer, and we're done. Okay, so what I'd like to do now, I'd like to do a couple more problems just like that. The algebra maybe gets a little bit tricky in these next couple problems, so that's what's important here. And in fact, we'll just tell you straight off that these functions are one-to-one, so we don't have to worry about that. And we'll just go through the four-step process to find the equation of the inverse function. So let's do that. So let's see here. So step 1 is going to be to replace h of x with y. Y equals 4 over x minus 8. And then step 2 is to switch x and y. So x is equal to 4 divided by y minus 8. And now we need to solve for y. So step 3 is now solve for y. And probably the quickest way to get started on that is to multiply both sides by the least common denominator. Or another way to say that would be to say cross multiply. So on the right side, the y minus 8's cancel, and we're just left with 4. And on the left side, we have x times y minus 8. And there are two ways now that you could solve this. Probably the quickest way, maybe the most elegant, would be just to divide the x off. And so the x's cancel, and you're just left with y minus 8 equals 4 over x. And then if you add 8 to both sides, you get 4 over x plus 8. Yep. Back up here, you could have distributed the x and had x times y minus 8x equals 4. And then going on from there. And that would have been fine too. But I don't think we have to write that out here. You can try that. You could leave your answer just like this, 4 over x plus 8. Or if you wanted to, you could find a common denominator. That would be a denominator of x. So you would write this as 8x over x. And then you could add the numerators and get 4 plus 8x over x. And that's the form that you would come out to if you had distributed the x back here at the beginning of step 3. So two ways to write our answer. The only thing left is to go ahead and call it by its formal name, which is h inverse of x. H inverse of x, and then we'll be able to box it up. So h inverse of x is equal to 4 over x plus 8, or we could write h inverse of x is equal to 4 plus 8x over x. And there you go, we found the inverse of a rational function. Okay, so let's do it one more time. This one will be a little bit trickier just because x shows up in the numerator and the denominator. But there's some good algebra here. So let's have a look. So step 1 is going to be to replace f of x with y. Y equals 2x plus 3 over x minus 4. Oh, I should invite you to stop the video and try to work the problem out on your own. There is a tricky step coming. Okay, so step 2 is to go ahead and switch x and y. So where we see y, we put x, and where we see x, we're going to write y. 2y plus 3 over y minus 4. And then we can go ahead and solve for y. We can multiply both sides by y minus 4, and we'll have x times y minus 4 is equal to 2y plus 3. And so now we need to solve for y. And we have y on both sides of the equation. We need to get the y's all together on one side, and we need to get everything else over to the other side. So at this point, what we really want to do is distribute the x. So we'll have xy minus 4x is equal to 2y plus 3. And then we can group the y's together on the left side. To do that, we would subtract 2y on both sides. And the terms that don't have y would go over to the right side. So in particular, that would be this 4x that needs to move out of the way over to the other side. And so 4x's cancel on the left and 2y's cancel on the right. And we're left with xy minus 2y is equal to 4x plus 3. Okay, so that's a real good step. And then there's another real good step. How are we going to get y by itself? The key now is to go ahead and factor out the y. So y times x minus 2. Common factor of y in both terms needs to come out in front. What's left over is x minus 2. And then on the other side, we just have 4x plus 3. And I bet you can see the last step is going to be to divide both sides by x minus 2. And we'll have y is equal to, x minus 2's cancel, you'll have y is equal to 4x plus 3 over x minus 2. And you can go ahead in step 4 and call that f inverse of x. And we have our final answer. Sometimes I see students try to take a shortcut on this process. They try to find a pattern or try to anticipate what the inverse is going to be just by looking at the original function. You really don't want to do that. You really want to go through the steps and see what you get at the end.